You have been fasting correctly and getting it wrong at the same time. Every morning you skip breakfast. You feel sharp, controlled, disciplined. You are running what looks like a clean 16-hour fast on paper. And somewhere inside that window, silently without any signal you can feel, your body is dismantling the single most important benefit that fasting was ever supposed to produce. Not because you are doing something wrong, not because you lack information, but because there is a biological mechanism sitting inside benefit number one that almost nobody in the mainstream wellness space has ever explained to you. And without understanding it, you are generating the hormonal environment that shuts it down at the exact moment it should be accelerating. I'm going to walk you through that mechanism in real time, stage by stage, starting from hour zero. Before this chapter ends, you will understand exactly what benefit number one actually is at the cellular level, what controls it, what kills it, and why the answer has been sitting in peer-reviewed journals for nearly a decade while fasting content kept talking about insulin spikes and eating windows. The invisible villain in this video is not food. It is not a macronutrient. It is a signaling molecule your body produces independently of anything you eat, and it operates on a timeline that has nothing to do with your last meal. Its name is mTOR, mechanistic target of rapamycin, and if you have never heard that name before, that is not your fault. It is the fault of every fasting guide that stopped the explanation at insulin. Let me give you the context that makes everything else click. In 2016, a Japanese cell biologist named Yoshinori Ohsumi received the Nobel Prize in Physiology or Medicine for mapping the molecular machinery behind a cellular process called autophagy. The word comes from the Greek for self-eating. What Ohsumi documented was the mechanism your cells use to identify damaged proteins, worn-out organelles, and accumulated cellular debris, and then systematically break them down and recycle the raw materials. Think of it as the overnight cleaning crew. When the warehouse closes, when no deliveries are coming, when the loading dock goes quiet, the maintenance team moves in. They pull broken equipment off the shelves. They discard what cannot be repaired. They rebuild functional structures from recycled parts. That process is autophagy. And it is not a fringe wellness concept. It is one of the most consequential cellular maintenance mechanisms in human biology. Research from institutions including the Buck Institute for Research on Aging and multiple European geroscience centers has linked declining autophagy activity to the accumulation of damaged protein aggregates that drive neurodegenerative disease, to the malfunctioning organelles that compromise cardiovascular tissue over decades, and to the accelerated cellular aging that begins to express itself clinically in your 50s. This is the benefit that makes fasting something genuinely distinct from simply skipping meals. Not fat loss, not insulin sensitivity, though both of those matter. The cleaning crew, the cellular reset, the mechanism that, when operating at full capacity during an extended fast, is doing something no supplement on the market can replicate at the molecular level. Here is where the story gets specific. Autophagy is not regulated by calories. That is the foundational misunderstanding that has sent millions of people through 16-hour fasts, believing they were generating this benefit when, biologically speaking, they were barely touching it. Autophagy is regulated by mTOR. When mTOR is active, autophagy shuts down. The warehouse manager calls in the full crew, clears the loading dock, and the cleaning team is dismissed before they finish. When mTOR is suppressed, when the system receives sustained signals of scarcity, autophagy runs. Those two states cannot coexist. The cleaning crew and the construction crew do not operate simultaneously. The body does not repair and build at the same time. It is one or the other, and the switch is mTOR. What activates mTOR? 3 inputs, each operating on a different timeline. The first is amino acids, specifically leucine, which is found in high concentrations in animal protein sources, including whey, eggs, and meat. Even trace amounts of free leucine in the bloodstream are sufficient to push mTOR toward activation. The second is insulin. When blood glucose rises and insulin follows, mTOR receives a nutrient availability signal that ends the maintenance window. The third is the one almost nobody talks about in fasting content, and it is the one that explains why your 16-hour fast is producing far less autophagy than you think. It is cortisol-driven gluconeogenesis. Your body manufactures glucose from non-food sources every morning before you consume a single calorie. Your liver takes amino acids, glycerol from fat breakdown, and lactate from muscle activity, and converts them into glucose through a process called gluconeogenesis. This is not a flaw. It is one of the most ancient survival mechanisms in human physiology. The body fueling itself through the first hours of the day without requiring you to eat immediately upon waking. But here is the problem. That manufactured glucose enters your bloodstream. Blood glucose rises, insulin follows, and mTOR activates. The cleaning crew receives an eviction notice not because you ate something, but because your own liver produced fuel and your own pancreas responded. This happens every morning, every single morning. The only question is how aggressively it happens. And that is determined almost entirely by one thing: cortisol. The cortisol awakening response is one of the most well-documented hormonal events in psychoneuroendocrinology. Within 30 to 45 minutes of waking, your cortisol level rises between 50 and 160% above its overnight baseline. This spike exists because the human body spent hundreds of thousands of years waking into physical environments that required immediate action. Cortisol is the biological starting gun. It raises alertness, sharpens attention, and sends a direct signal to your liver: produce glucose now. The more aggressively cortisol spikes, the more aggressively gluconeogenesis runs. The more glucose the liver produces, the larger the insulin response. The larger the insulin response, the earlier and more completely mTOR activates. The cleaning crew, which was perhaps building toward meaningful operational capacity during the overnight hours of your fast, receives that eviction notice before it ever reaches peak efficiency. For most adults over 50, this sequence is even more consequential than it is for younger people. Research from several aging physiology groups has documented that insulin sensitivity declines measurably each decade after 40. The same cortisol-driven glucose release that produces a modest, brief insulin tick in a 35-year-old produces a larger and longer-lasting insulin response in a 55-year-old. The cleaning crew does not merely take a longer break. In someone with any degree of insulin resistance, and data from the Centers for Disease Control and Prevention shows that approximately 40% of American adults have prediabetes or impaired fasting glucose. That cleaning crew barely gets organized before the next eviction notice arrives. 4 in 10 people, not a fringe population. 4 in 10 Americans are walking around with a metabolism that overreacts to this exact mechanism every single morning. Dismantling the autophagy window they believed they were protecting with 16 hours of discipline. Now overlay this onto the standard 16-hour fast. Your eating window closes at 8 in the evening. By 6 in the morning, you are at 10 hours. Your cortisol awakening response has already begun. By 6:30, gluconeogenesis is running. By 7, insulin has risen enough to begin mTOR activation. The cleaning crew, which was building momentum through the night, stops working. By the time insulin falls and the pathway reopens, roughly 90 minutes in a metabolically healthy person, potentially 3 hours or more in someone with insulin resistance, your supposed 16-hour fast has delivered perhaps 8 to 10 hours of meaningful autophagy activity instead of the 14 or 15 hours it was theoretically capable of producing. You did not break the fast with calories. You broke the benefit with a hormonal chain reaction that your body triggered entirely on its own, and the mechanism does not stop there. Because sitting inside the cortisol story is a second mechanism that most fasting content has never addressed, and it is the one that explains something millions of people have experienced and never been able to explain: the inexplicable hunger or cognitive fog that hits around 10 or 11 in the morning during a fast, even after consuming zero food. That mechanism runs through adenosine, the same cortisol amplifier that most people pour into their first cup of the day, but that is where the next chapter begins. Adenosine is a chemical that accumulates in your brain during every waking hour. The longer you are awake, the more it builds. It is the molecule responsible for the progressive heaviness you feel as the day goes on, the biological pressure that tells your body sleep is coming. After a full night of sleep, adenosine is at its highest overnight concentration. The cortisol awakening response is partly designed to manage this load, clearing it through natural metabolic pathways over the first 1 to 2 hours of the morning. That natural clearing process is your body handling its own chemistry at its own pace. It works. It has worked for hundreds of thousands of years. The problem arrives when you interrupt it. Most people who practice intermittent fasting wake up and immediately reach for coffee. The logic is obvious and has been repeated across every fasting podcast, every wellness newsletter, every fitness account that has ever addressed the question. Black coffee contains essentially 0 calories. A standard 8-ounce cup sits somewhere between 2 and 5 calories. The insulin index of plain black coffee, its direct power to raise insulin through caloric content alone, is negligible. That part is true. And the mainstream fasting conversation has treated the insulin index of a substance as the only mechanism that matters. That framing is incomplete in a way that is actively costing you results. Caffeine is not a food, it is a pharmacologically active compound that acts directly on your central nervous system, and it has a documented, measurable effect on cortisol that has nothing to do with its calorie count. Research by William Lovallo and colleagues at the University of Oklahoma Health Sciences Center, published in Psychosomatic Medicine, demonstrated that caffeine consumption significantly amplifies cortisol responses, not just in occasional coffee drinkers, but in habitual coffee drinkers as well. When you consume caffeine during the cortisol awakening response window, that first 30 to 45 minutes after waking, you are adding fuel to a fire your body already lit. The cortisol spike that was going to peak naturally at a certain level now climbs higher. A higher cortisol spike means a more aggressive gluconeogenesis response. The liver produces more glucose, more insulin follows, and the cleaning crew, which was already under pressure from the natural morning cortisol rhythm, receives an early eviction notice 2 to 3 hours before your eating window was supposed to open. Here is the full mechanism in sequence. Caffeine works by blocking adenosine receptors. Adenosine is at its highest overnight concentration the moment you wake up. The cortisol awakening response is partly designed to clear it. When you flood those receptors with caffeine at the precise moment the cortisol system is trying to do that work, you create a forced stimulation that overshoots the system's natural trajectory. The cortisol does not peak and decline in its normal arc. It climbs higher and stays elevated longer. Researchers at the University of Bristol, examining caffeine and cortisol dynamics in morning consumption, found this effect was most pronounced specifically during the early waking window. The timing is not incidental. It is physiologically loaded. Now back to that mid-morning hunger. Because caffeine does not eliminate adenosine, it only blocks the receptors it acts on. Adenosine continues accumulating behind the blockade. Over the next 2 to 3 hours, as caffeine is metabolized and its half-life begins working against you, those blocked receptors open back up, and all the adenosine that built up while the blockade was in place floods them simultaneously. This is the mechanism behind the crash at 10 or 11 in the morning, not low blood sugar, not genuine hunger. A retroactive adenosine wave hitting all at once. Your reward-seeking brain circuitry interprets the sudden drop in perceived energy and focus as a need for fuel. You reach for food, another coffee, or something with sugar. Not because your body needs caloric input, but because your adenosine system has been destabilized by the timing of the first caffeine dose. The hunger at 10:30 is largely a pharmacological artifact of the 6:45 cup. The fast becomes harder to hold, not because of insufficient willpower, but because the neurochemical system that generates appetite has been primed to fire early. This is the invisible villain in your morning routine, not the coffee itself. The timing collision between caffeine's cortisol amplification effect and the cortisol awakening response window, and that collision is more damaging for anyone over 50 than it is for younger adults, for a reason most fasting guides will never mention. Caffeine's half-life in the average adult is approximately 5 to 6 hours. In adults over 50, that half-life can extend to 7 or 8 hours due to age-related reductions in CYP1A2 activity, the liver enzyme primarily responsible for caffeine metabolism. An 8 in the morning cup is still pharmacologically active in your system at 3 or 4 in the afternoon if you are in the over 50 demographic. The cortisol amplification effect extends further into your day than it did at 30. This has implications not only for the fasting window and autophagy, but for afternoon cortisol levels, sleep quality, and the hormonal baseline you carry into the following morning's cortisol awakening response. A poor cortisol baseline from the previous day creates a higher amplitude cortisol awakening response the next morning, which makes the timing collision more damaging, which degrades sleep quality further. the loop compounds, and the population most affected by this loop is exactly the population most invested in fasting for metabolic repair. I want to include something here that intellectual honesty requires. Coffee is not the enemy. The research on habitual coffee consumption and long-term metabolic health is, on net, positive. Chlorogenic acids, the polyphenolic compounds in coffee, improve insulin sensitivity over time through effects on hepatic glucose metabolism. Habitual coffee drinkers show meaningfully lower risk of type 2 diabetes than non-drinkers. One pooled analysis drawing on hundreds of thousands of participants found that each additional daily cup was associated with approximately a 6 to 7% reduction in type 2 diabetes risk. The paradox is this: the compound that causes the acute cortisol-driven insulin problem in the morning is the same compound that, consumed consistently over months and years, improves the insulin sensitivity that makes that acute problem more manageable. The answer is not to stop drinking coffee. The answer is to consume it at the right point in your morning hormonal arc, where the cortisol system has already peaked and declined and the adenosine load has been cleared on its own. It is a calibration problem, not an elimination problem. There is a layer here that goes deeper than the cortisol pathway, and it connects to the circadian biology that earned 3 American scientists, Jeffrey Hall, Michael Rosbash, and Michael Young, the Nobel Prize in Physiology or Medicine in 2017. 2 consecutive Nobel Prizes in physiology connected to the same fundamental biological system. Your body does not experience time as a neutral backdrop. Every organ, every hormone, every cellular signaling pathway runs on a biological clock tied to the light-dark cycle of the earth. The liver has its own circadian clock, independent of the master clock in the brain's hypothalamus. The pancreas has one. The adrenal glands have one. These clocks regulate the sensitivity of every system to the hormones that pass through them. Cortisol sensitivity at 6 in the morning is not the same as cortisol sensitivity at 2 in the afternoon. The liver's enzymatic machinery for converting amino acids into glucose, the gluconeogenesis pathway, runs at its highest daily expression level between approximately 5 and 9 in the morning. Caffeine hits a cortisol system that is already at its daily peak sensitivity, driving a gluconeogenesis pathway that is simultaneously at its daily peak capacity. The timing does not simply add bad effects together, it multiplies them. Evening coffee drinkers, people who have a cup at 2 or 3 in the afternoon consume the same drug, the same caffeine content in the same beverage, but the cortisol system is at a different point in its daily arc. The gluconeogenesis machinery is less active. The insulin response to the same blood glucose signal is, in many people, more efficient and more brief. This is not an argument that afternoon coffee is universally safe during a fast. It is an illustration that timing is a biological variable, not a personal preference. The compound is the same. The circadian context changes everything about what the compound does. I had most of this information piecemeal about 5 years ago. I was reading about cortisol, about intermittent fasting, about autophagy. I was fasting, pouring black coffee at 6:30 every morning, and genuinely not understanding why my metabolic markers were moving only a fraction of what the literature suggested. It was not until I mapped the timing collision, specifically the interaction between the cortisol awakening response and the first caffeine dose, that things shifted. After my cardiac event, which ended with paramedics and a prescription for 4 medications I was told I would take for the rest of my life, my wife became the one who handed me the research papers while the doctors handed me the bottles. I read both, and what the papers showed, once you understood the circadian layer, was that I had been running the right protocol at the wrong time of day, breaking the most important benefit silently every morning before breakfast, before any food, just from the timing of a cup of coffee I had been drinking for 30 years. Understanding the mechanism did not automatically translate into a morning that executed correctly. That required a structure, and structure is what the next chapter delivers. 3 components, each with exact numbers, that protect the autophagy window you are already generating without extending your fast, without giving up coffee, and without a single change to your eating window. Here is what your body is supposed to do during a properly executed fast. In the first 12 hours after your last meal, insulin falls as liver glycogen depletes. The cleaning crew begins trickling in as the loading dock quiets. The transition is a gradient, not a switch. Between hours 12 and 16, with insulin genuinely low, autophagy activity becomes measurably elevated. Between hours 16 and 24, the cleaning crew reaches full operational capacity across multiple tissue types: brain tissue, cardiovascular tissue, and metabolically active muscle. This is the window where fasting stops being about weight and starts being about cellular architecture. Now overlay the cortisol problem onto that timeline. Your fast begins at 8 in the evening. By 6 in the morning, you are at 10 hours. You pour coffee at 6:30. The cortisol that was going to peak naturally now climbs higher. Gluconeogenesis accelerates. By 6:45, insulin has risen enough to push mTOR back toward active suppression of autophagy. The cleaning crew receives an eviction notice and waits. By the time insulin falls again, 90 minutes in a metabolically healthy person, 3 hours or more in someone with insulin resistance, you have biologically generated somewhere between 8 and 10 hours of meaningful autophagy instead of the 14 or 15 you were capable of producing. Quietly dismantled before you ate a single calorie. The 3-component protocol that addresses this is called the CLEAR protocol. It has 3 components, each with a specific number and one common mistake at the end that will invalidate all 3 if you make it. The C stands for cortisol window. No caffeine in the first 90 minutes after waking. Set the timer if you have to. Not from when you get out of bed, but from the moment you open your eyes, because the cortisol awakening response begins at the moment of conscious arousal. 90 minutes is the evidence-based minimum for allowing the natural cortisol arc to peak and begin its decline before caffeine amplifies it. People over 50, or anyone with high baseline cortisol from chronic stress or poor sleep quality, should consider extending that window to 120 minutes. The mechanism behind this adjustment is precise. By waiting 90 minutes, you allow the cortisol peak to reach its natural ceiling and begin falling before caffeine arrives. The gluconeogenesis response the liver runs during the cortisol awakening response is already happening. You cannot stop it entirely, but you can avoid amplifying it. The difference between a natural cortisol peak and a caffeine-amplified cortisol peak is the difference between a modest, brief insulin tick and a sustained mTOR activation event that ends the cleaning crew's shift early. During this 90-minute window, you can have plain water, sparkling water, and electrolyte water. A 1/4 teaspoon of sea salt dissolved in 16 ounces of water is sufficient to maintain electrolyte balance without triggering an insulin response. Sodium does not prompt insulin secretion. Maintaining cellular electrolyte balance during the final hours of your fasting window supports the lysosomal function autophagy depends on without triggering an insulin response or compromising the fasting state in any measurable way. The L stands for light anchor. Within 10 minutes of waking, expose your eyes to natural light, not through glass if possible. Direct outdoor exposure for 2 to 5 minutes is sufficient. If you are inside, position yourself near the brightest available window and remain there for 10 minutes. This is not a wellness suggestion. It is a circadian trigger with a documented neurological pathway. Morning light exposure activates the retinohypothalamic tract, the connection between your retina and the suprachiasmatic nucleus, which is the brain's master circadian clock. This signal sets the rate of adenosine clearance for the day. When you anchor your circadian system with light before caffeine arrives, the adenosine system runs its natural clearing process on a more efficient schedule. The caffeine you consume 90 minutes later works on a more favorable adenosine baseline, producing less overshoot, a shallower crash curve in the mid-morning, and significantly less of the appetite surge that shortens fasting windows behaviorally. The light anchor does not replace the cortisol window. It makes the cortisol window easier to hold by reducing the sensation of dragging through the first hour without caffeine. The 2 components work together. The E stands for eating anchor, specifically the composition of your first meal when the fasting window closes. This is where millions of people execute the first 2 components correctly and then undo everything in the final step. When your eating window opens, the temptation is to reach for something that feels healthy and quick. A piece of fruit, a bowl of oatmeal with honey, a smoothie built around banana and dates, or a protein shake. These feel like virtuous choices. From an mTOR standpoint, they are some of the most disruptive moves you can make at this specific moment. Fruit delivers fructose and glucose directly into the portal blood supply, producing a sharp insulin spike that terminates fat oxidation almost immediately. A protein shake delivers a concentrated leucine load, and leucine, as described in Chapter 1, is one of the most potent direct activators of mTOR. If you have been running clean autophagy for 14 to 16 hours, and your first meal is a whey shake consumed alone, you generate the steepest possible mTOR spike at the precise moment when the cleaning crew is operating at its highest productive intensity. The session ends abruptly. The more effective approach, supported by clinical trial data from Dr. Krista Varadi's lab at the University of Illinois, Chicago, one of the most rigorous bodies of human data on time-restricted eating currently available, is to precede the protein with fiber and fat. A small quantity of olive oil, avocado, or fibrous vegetables consumed first slows gastric emptying and blunts the rate of amino acid absorption. The mTOR activation still occurs. You want it to. Protein synthesis and muscle maintenance require mTOR signaling, especially after 50 when muscle loss accelerates. But when the activation rises gradually rather than sharply, the final segment of your fasting window completes more fully before the warehouse manager calls in the full crew and shuts down the audit. Varadi's trial data over 12-week periods showed greater lean mass preservation in the groups who led with fiber and fat at meal 1 compared to those who broke the fast with carbohydrate-dominant or protein-first meals. The practical target is a tablespoon of olive oil, half an avocado, or 20 to 30 grams of fiber-containing vegetables consumed before the protein component of the meal. That sequence is the difference between a clean, close to the autophagy window and an abrupt shutdown. 3 components: 90-minute cortisol window, 10-minute light anchor within waking, fiber and fat before protein at the eating window. These are not refinements. They are the protocol. And now the mistake that invalidates all 3, because this is the piece of insider knowledge that most people attempting to implement any fasting protocol never encounter. The mistake is conflating the 90-minute coffee delay with the eating window opening. People who correctly delay their coffee and then immediately follow it with a protein shake or Greek yogurt have solved the cortisol problem and replaced it with an mTOR problem. The 90-minute coffee delay and the eating window opening are 2 separate calibrations that operate on different biological timelines. The coffee delay protects the cortisol arc and preserves the final hours of the autophagy window. The eating window opening is a separate event governed by your fasting protocol that should happen at its designated time, not immediately after the delayed coffee. Conflating the 2, treating the 90-minute mark as simultaneously the moment for coffee and the moment to break the fast, is the most common structural error that occurs when people attempt to implement the clear protocol. The reason this error is so universal is not a failure of willpower. It is a designed outcome of how the morning coffee ritual has been built into modern life. Coffee is sold as a first-act product, something you do before anything else. The rational brain hears the 90-minute delay, understands the mechanism, and then the habitual brain, faster, older, more automatic, overrides it on day 2 or day 3. The solution is structural, not volitional. A coffee maker programmed to start at 7:30 instead of 6. Coffee supplies position so that reaching them requires passing through the light anchor space near a window, an electrolyte glass pre-prepared next to the bed, so the first automatic reaching motion goes toward water. The behavior change is upstream of the decision point. Willpower applied at the moment of temptation is the most expensive and least reliable form of self-regulation available. Your morning fast is more fragile than you were told. The invisible villain is not what you eat, it is a timing collision between a predictable hormonal event and a behavioral habit that has been commercially optimized for your immediate convenience, not your long-term cellular biology. The cortisol awakening response runs every morning whether you manage it or not. The only question is whether you allow caffeine to amplify it into a gluconeogenesis, an insulin signal that sends the cleaning crew home early, or whether you let the system run its natural arc and deliver the caffeine when the loading dock is already quieting down on its own. The clear protocol is 3 moves: a 90-minute coffee delay from the moment your eyes open, morning light exposure within 10 minutes of waking, and the first meal that leads with fiber and fat before protein to blunt the mTOR spike at the close of your fasting window. Those 3 adjustments, consistently applied, protect the autophagy window you are already generating. You do not have to extend your fast. You do not have to give up coffee. You have to fix the timing. If you are going to start the clear protocol this week,